अच्छा, we were doing past papers organic है, ठीक है, and साथ ही मैंने notes खोले हुए, we going to go over them as well, ठीक है, कोई भी चीज होगी उसको revise करेंगे. Now this question is about AS. उससे क्या है, there's a hormone and give the number of primary, secondary and tertiary alcohols groups in one molecule of जो भी molecule है. Uh, Now what was पहले revision? What was a primary alcohol? Primary alcohol was if there is a carbon with an OH group, okay, so if there's a carbon, this type of carbon, and on one side it is attached to a carbon chain, let's call that R, and on two sides there are hydrogen. That's a primary alcohol. Okay, what's a secondary alcohol? Okay, you have a carbon with an OH, and on two sides there are carbon chains. Uski do sides pe na there are carbon chains, and on one side there is H, so that's a secondary alcohol, and then you had a tertiary alcohol, just kind of you had OH, and on three sides there are carbon chains in that molecule. Okay, that's a tertiary alcohol. Now in this molecule you are being asked to figure out which molecule is which OH group is primary, secondary or tertiary. Now if we start with this one, okay, this one over here, if you look carefully over here, you would notice that this carbon atom, uske top में there's a carbon chain, and this side there's a carbon chain as well. So on all three sides there is a carbon chain. So that type of alcohol or that type of carbon is a tertiary alcohol. So I'm going to write tertiary next to it. ठीक है, आयशा clear है? महफूज clear है ये? So then you have this carbon atom over here. If you focus on this, so in this molecule, this carbon atom is uske ek side pe there's a carbon chain, on the other side there's a carbon chain. So there are two carbon chains. Uh, so that's basically your secondary alcohol. Okay, this over here is your secondary alcohol. And this other carbon is also going to be a secondary alcohol. Okay, if you focus on this carbon atom over here, then you're going to notice that this carbon atom has a carbon chain on one side and a carbon chain on the other side. So that's also a secondary alcohol. So basically, you say he had asked you for the number of primary, secondary. So there is no primary. Okay. There are two secondary alcohols and there's one tertiary alcohols. Then you have give the name of the chiral carbon atom in one molecule of give the number of chiral carbon atoms. Okay, number of chiral carbon atoms. पहले तो let's briefly discuss what was chirality. Although it's that's also part of AS. ठीक है, लेकिन we'll just do a brief revision first of what a chiral molecule is. इसमें enantiomers होते थे, and now this is all revision. ठीक है, old AS concepts. So you have a chiral carbon atom. A chiral carbon atom is one where on all four sides of the carbon atom, remember when carbon is making single bonds, it has a tetrahedral shape around it. It has four bonds, and all four bonds are going to be different. Okay, so there's going to be W over here, and there's going to be X over here, and there's going to be Y over here, and all four sides are going to be different. And that is why that particular carbon atom is going to be a chiral carbon atom. And that molecule is going to have mirror images. Okay, there's going to be another enantiomer, which would be exactly the reversed or mirrored version of the molecule. They look exactly the same. Okay, the two enantiomers or optical isomers, they look exactly the same, except that they are mirrored or reflected versions of each other. Okay, like your two hands. Okay, your two hands, they look exactly the same, except that they are not the same. उनकी directions different होती है. ठीक है, your fingers are pointing in the wrong direction. मतलब एक हाथ को आप जिस तरह मर्जी घुमा लो, it's not going to look like the other hand. So that's what chirality is. So you'll have two molecules and they're going to be chiral, and this is your chiral carbon atom. So basically, as a chiral के अंदर होता था कि the molecules have pretty much the same physical and chemical properties, but when it comes to complicated molecules with complicated structures, the shape matters. ठीक है, biological functionality के अंदर this is very important. But let's say imagine कर लो कि there's a glove, ठीक है. अब उस glove में आपका left hand enter हो जाएगा, but you can't fit your right hand in that glove. क्योंकि obviously जहाँ पे thumb है दूसरा हाथ enter करोगे तो biological functionality is similar to that कि it's very shape specific. The molecules are complicated and they have to fit in a very specific manner. So chirality is very important biological functionality, but otherwise the two are going to behave pretty much the same way. So that's revision. So coming back, अब हमने इस molecule के अंदर, this is a large molecule and we have to figure out which atoms are chiral. Now I'm going to start one by one. पहले तो सबसे पहले, and you have to give the number of chiral carbon atoms. Yani it's a long molecule and you have to find out each and every single chiral carbon atom in this molecule. So it's going to take some time. We're going to pick. Let me pick a different color first. So now one by one. Let's start with this carbon atom over here. Okay, now this carbon atom, on three sides, this side is different. ये वाली side भी different है. This side is different. Now this is a skeletal formula, which means that on the fourth side there's going to be an H. Now this one is chiral because all four groups are different. All four. This side is different. This side is different. This side is OH. This side is H. So all four sides are different for this molecule. So this one is chiral. Any carbon which doesn't form double bonds is not chiral. Okay, so this is definitely not chiral. So what about this one, this carbon atom? This carbon atom is bonded on two sides with carbon chains. So the third and the fourth bond will be with hydrogens. Now, if those bonds are with hydrogen, then it can't be chiral because two of the groups are going to be exactly the same. Here you have OH. This is going to be chiral again because the fourth bond of this carbon atom would be with an H. So on one side there is an H, on one side there's an OH, on one side there's a carbon chain, on the other side there's a carbon chain, but it's a different type of carbon chain. So abhi tak two mile. So this one is not chiral because it's going to have the third and the fourth bond will be with hydrogens. Then moving on, this one can't be chiral because it's a double bond. This one can't be chiral because it's a double bond, double bond, double bond. So double bond वाले तो सारे चले गए. अच्छा इस वाले part के अंदर we've only found two chiral atoms so far. इसमें figure out करते हैं this carbon atom, it's making two bonds, two hydrogens, so that's not chiral. Two bonds on two sides, they're going to be hydrogen atoms, so that's not chiral as well. So these are definitely not chiral because they're two hydrogen atoms. Let's look at this one. This one is going to be chiral. Why? Because all four sides are different. Upar there's a carbon chain. Here there's a different type of carbon chain. Here there's a different type of carbon chain. Niche there's a different type of carbon chain. So all carbon chains, all sides, they appear to be different. Okay, over here, it's different. Different things are attached. Over here, it's different. Over here, it's different. So this one is chiral. And so is this one because there's going to be one H. The fourth bond will be with H. So top side is different. This side is different. This side is different. So all sides are different. So ye wale are not chiral because each one will be bonded to two hydrogens. This one will be bonded with one more hydrogen, fourth bond, and it's going to be chiral. Okay, because all four sides, one side is hydrogen, one side is this side, one side is this side, and the fourth side is this side. Okay, this one is going to be chiral as well. The fourth bond will be with hydrogen. So all four sides, ऊपर carbon chain है, इस side पे ये chain है, इस side पे ये chain है. So this one is also chiral. All four sides are chiral. These are not going to be chiral because so why? Because two hydrogens. This one also not chiral, two hydrogens. This one is also not chiral, two hydrogens, and this is also not going to be chiral because two sides are going to be exactly the same. The carbon chains, ऊपर वाली carbon chain, ये वाली carbon chain, they are exactly the same. So you needed all four groups to be different. So is सारे के अंदर how many chiral carbon atoms have you figured out? That's 1, 2, 3, and 4. So इस part के अंदर there's 4 chiral centers. Abu Rana, clear है ये? Aisha, is this clear?
Yes, sir.
So in total you have how many chirals? You have 7. So you have 7 chiral atoms. Next is he's saying it shows geometrical isomers. Give the number of geometrical isomers of this molecule. So पहले तो brief description of what a geometrical isomer was. A geometrical isomer was that उसके लिए दो शर्तें थी. One was that you need to have a double bond, and the double bond must be bonded to 2 different groups. ठीक है? So मतलब if this is CH3, then this side must be different, probably H. This side is CH3, then this side would be different as well. So the double bond on both sides must be bonded to 2 different groups. I mean, the first condition is that you need a double bond. And then the double bonded carbon atoms, this carbon atom must be bonded to 2 different groups. And this carbon atom must be bonded to 2 different groups. आपस में वो बेशक group same, or we don't care. But this carbon atom must be bonded to 2 different groups, and this must be bonded to 2 different groups. This one is the cis version. And this other one that I'm going to draw will be the trans version. उसमें क्या होगा कि instead of the CH3 pointing upwards, the CH3 would be pointing downwards and the H would be pointing. So this side would be switched. Then the CH3 instead of pointing upwards is pointing downwards, and that's your trans version. So again, I repeat essential conditions that number 1, carbon double bond carbon has to be there. And number two is that each atom, not atom, each carbon in C double bond C must be bonded to 2 different groups. Different. I said must be bonded to 2 different groups. अब बोले आवाज आ रही है? अच्छा अब इस molecule we have to decide whether this molecule can have cis and trans isomers in total. Now for that the first thing is we need to ये वाला part पहले रब कर लेते हैं. ठीक है, let's double bonds के लिए. ठीक है, I'm removing the working around the double bonds. ठीक है, secondary वाला part. ठीक है, that's gone. Now first thing, let's focus on this double bond. This double bond has a carbon over here, and it's going to be bonded to it's going to be bonded to 2 hydrogens. So if it's bonded to 2 hydrogens, so if it's bonded to 2 hydrogens, then it can't be chiral. Because side, even if you switch the side, it's not going to be a chiral molecule. So that is definitely not possible. Then you have the double bonds over here. The double bonds over here can be made chiral. I mean, there's a double bond over here and a double bond on this side. Now, there are 2 ways that this double bond can be made chiral, and that is, okay, remember, focus on this, that there is a hydrogen over here. Okay, so chirality does apply to it. Now imagine this entire molecule. Okay, it's attached to this double bond, and there is H over here. Now they could exist, इस नीचे वाले को रब कर लेते हैं. So now there could exist two versions of the molecule. One is okay, this bond is pointing in this direction. Okay, let's focus on this carbon atom first. Okay, let's focus on that. Let's rub this off as well. And let's focus on this. So there's a double bond and there's a carbon chain over here and an H over here. Now this could be flipped. This carbon chain which is going over here could be made to point in the other direction. And the H could point in this direction. But this entire molecule over here, this entire molecule, instead of being attached on this side, it could be attached on this side. So that's two possible isomers. Okay, you're going from, I mean, there's a double bond. Instead of going here and then attaching this, you could go over here and then attach this entire thing. आयशा ये बात समझ आइए?
जी सर.
तो आपका the double bond that's going to be this one can have exist in a cis or a trans version. Okay, so that would result in the formation of a cis trans isomers. It could either be pointing in this direction or this entire thing, ये पूरा molecule जो है, it could be pointing इस side पे point करके attach हुआ होगा. And this one is also cis trans, लेकिन दोनों का जो cis trans है ना वो overlap कर रहा है कि, but it would mean the same thing कि अगर मैं इसके point of view से cis trans discuss करता हूँ ना, but this carbon atom is going to do the same thing. It's either to the right, ये जो ऊपर वाली चीज है, it could either be bonded to the right side or it could point इस side को flip करके ना, this bond instead of pointing in this direction, it could be pointing in this direction और फिर यहाँ पे जाके ये पूरी चीज attached हो. So it's going to result in exactly the same thing. So there's actually just one cis and trans version of the molecule. ठीक है कि नीचे वाले को flip करो, you'll get the same thing. तो यहाँ पे ना बेसिकली इधर से आ रहे हो या तो ये लेफ्ट जाएगा या फिर दूसरा वर्जन होगा कि यू गोइंग दिस डबल बॉन्ड और फिर आप राइट चले जाओ. और नीचे से अगर फ्लिप करोगे इट वुड मीन एग्जैक्टली द सेम थिंग कि यहाँ से आप जा रहे हो तो ऊपर राइट की तरफ आ रहा है ये मॉलिक्यूल, या फिर ये दूसरी डायरेक्शन में हो सकता है, यहाँ से आप जा रहे हो इस डायरेक्शन में एच आ जाए और ये पूरा मॉलिक्यूल दिस इज ऑन द अदर साइड. सो देयर इज जस्ट वन वर्जन ऑफ सिस ट्रांस फॉर दिस मॉलिक्यूल. The number of geometrical isomers that's going to be two. One is going to be cis and the other one is going to be trans. The next part is a sample of molecule is treated with an excess of hot concentrated acidified potassium magnate 7. There are three different carbon containing products of this reaction. One of these three products is shown. Predict the number. I say this is carbon 13 NMR spectrum, which we have not done. This paper ही खत्म हो जाता है. अच्छा let's move to the next organic question क्योंकि वो भी हमने नहीं पढ़ा. Just one second, let me open it. May June 16 क्या कर लेते हैं. अब हुरैरा आवाज आ रही है? हेलो नहीं, सॉरी अबू हुरैरा ही नहीं. अब्दुल्ला आवाज आ रही है? महफूज आवाज आ रही है?
जी सर आ रही.
अच्छा तो ठीक है. नेक्स्ट ऑर्गेनिक रिवाइज करें. ठीक है वो 1 सेकेंड. उसके क्वेश्चन पे आ जाते हैं. अच्छा, this one, ठीक है, remember notes हम revise भी करेंगे. अच्छा, so you have this organic question and this organic question. पहले तो रेट का क्वेश्चन है. अच्छा, रेट वाले ऑर्गेनिक रिवाइज करनी है तो ऑर्गेनिक पे स्टिक करते हैं. अच्छा, the question is, there's this reaction that's happening, ठीक है, we don't know what the reaction is. अच्छा, reaction is happening and it's an aldehyde reacting with OH. Now we haven't studied this reaction, ठीक है. uh, and it says कि गौर से देखो तो इसमें पहले ना ये H यहाँ से ना it takes away, वो H2O बन गया और यहाँ से NH is lost. अच्छा, anyways, then this H is lost and this negative ion, it goes and bonds with this carbon atom, etc. and so on. नहीं, actually ये भी रेट का क्वेश्चन है. ऑर्गेनिक से स्टार्ट कर लेते हैं. दिस वन नहीं, दिस इज क्रोमियम. ऑर्गेनिक कहाँ पे? जस्ट वन सेकेंड. ठीक है, ये as a state and explain the relative acidities of ethanol and phenol. Now we did this comparison of acids. तो उसमें you have ethanol. Ethanol is a very weak acid. ठीक है, it's the, मैं सारा रिवाइज कर देता हूँ कि ethanol is CH3CH2 and OH. As ethanol dissociates, ionizes very weakly, even less than water. So it's a weaker acid compared to water even, and it loses an H plus ion. ठीक है, तो the question is कि explain और state भी करो. ये तो हम पहले ही कर देते हैं कि it's a very relatively a weak acid. ठीक है, so it's relatively a very bad acid. So why is it a bad acid? क्योंकि carbon chain has electron donating effect. So negative charge over here, electron density is higher. So all the electrons, they get pushed to the oxygen atom. The carbon chain has an electron donating effect. So the negative charge is higher, and if the negative charge is higher over here, it's more dense. It's going to attract the H plus one back again. तो वो dissociate ही नहीं करेगा. तो आपने लिखना है कि जो आंसर आपने लिखना था वो ये था कि alkyl chains. अब्दुल्ला क्लियर है? अच्छा, alkyl chains have electron donating effect, which increases charge density it increases charge density on this ethoxide ion, जो भी है CH3 CH2, making it very unstable. मतलब negative charge इतना ज़्यादा हो जाता है कि it attracts this H plus one back again, making it very unstable. As anyways, that's for alcohols. तो ये phenols का क्या issue है? Why are phenols such good, not a good acid, relatively strong acids? तो phenols में होता है कि phenols also dissociate. You have benzene and OH and it's in equilibrium. उसका जो phenol का end वाला H है, that breaks off, O minus one and H plus one is produced. But in this case, the negative charge is not localized over here. It's not concentrated over here. The negative charge ends up overlapping with the benzene electron cloud, and the negative charge density is lesser. If the negative charge density is lesser, then it would not attract the H plus one back again, and you're going to have more dissociation because the H plus one is, अगर वो form होगा, it's going to remain formed. It's not going to get attracted to it. तो इसमें आपने लिखना था कि जो आंसर लिखना था वो लिखना था कि lone pairs on oxygen, lone pairs on oxygen in this ion C6H5O minus 1 overlap with benzene's electron cloud, ठीक है, remember to write the answer in the proper way. So they overlap with benzene's pi electron cloud, making it more stable. It has negative lesser charge density. ठीक है, ये सारा हमने assets का comparison etc. We did this in a lot of detail somewhere over here. ठीक है, if you go over your notes again, तो यहाँ पे we also constructed a table which is this one. This table over here कि alcohols were the weakest acid. Alcohols का जो reaction था that it only happened with very reactive sodium, no other reaction. Phenols was slightly more acidic, so sodium and NaOH दोनों के साथ reaction होता था. Carboxylic acid were full-fledged acids, and they would react with sodium NaOH and sodium carbonate, carbonates, bases, and hydroxides, and sodium, all three. Or carboxylic acids. Why were carboxylic acids such good acids? क्योंकि negative charge जो होता था, there was an oxygen right next to it. So the electrons, they would get attracted to that oxygen, and the electrons, they eventually got distributed, which is why the negative charge density decreases a lot and the H+1 broke away. So carboxylic acids were very good acids, phenols were slightly good acids, and your normal alcohols, they were very bad acids. अब फिर इसमें different वो factors पढ़े थे कि if you, हमने different factors पढ़े थे. अच्छा, वो factors क्या थे? वो factors ये थे कि chlorine substituted. कहाँ पे गया? अच्छा, कि अगर उसी अल्कोहल के अंदर ये ऐड है क्लोरीन, तो क्लोरीन उल्टा इलेक्ट्रॉन्स अपनी तरफ खींचेगा, तो वो इलेक्ट्रॉन विड्रॉइंग इफेक्ट हो जाएगा. और अगर वो इलेक्ट्रॉन्स अपनी तरफ खींचेगा, नेगेटिव चार्ज कम हो जाएगा इसके ऊपर, इन H+1 will break away. ठीक है, it will no longer be attracted as strongly. ठीक है, Aisha, is this clear?
जी सर.
As okay, next part, moving to the next part. In the table below, give the reaction conditions for the formation of organic products D and E and draw the structures. So, using dilute nitric acid 5 degree centigrade के ऊपर the reaction is happening. Now, this would result in nitration. ठीक है, the phenol with its benzene ring is going to get nitrated. और कौन सी position के ऊपर NO2 would get attached to either 2 or it could get attached to position number 4, 2, 4, 6. ठीक है, इसकी पूरी कहानी पहले रिवाइज कर लेते हैं. ये नाइट्रेशन की जो कि हमने स्टार्ट में किया था, ये तो कंपैरिजन ऑफ एसिड्स SN1 SN2, ये सारा. अच्छा, इसके अंदर क्या था कि स्टार्टिंग राइट द बिगिनिंग, नॉर्मल बेंजीन के लिए द कंडीशंस वर रियली टफ. ठीक है, if you have a normal benzene or NO2 attached करना है, you need concentrated nitric acid and concentrated sulfuric acid, and the temperature has to be kept very high, 50 to 60, and only then would NO2 get attached. उसमें होता क्या था कि nitric acid and sulfuric acid, they would first react, and during the reaction they would produce this nucleophile, which is an electrophile, which is NO2 plus 1. फिर वो NO2 plus 1 ना इधर बेंजीन के इलेक्ट्रॉन क्लाउड से ना इलेक्ट्रॉन बोरो करके एक कार्बन के साथ जुड़ जाता था. तो that NO2 would make the benzene electron deficient. उसके इलेक्ट्रॉन वो खुद अपनी तरफ खींच लेता था, और अगले स्टेप में H would give its electrons back, and when it did that, तो बेंजीन का इलेक्ट्रॉन क्लाउड वापस पूरा हो जाता था. ठीक है, सर यहाँ पे H अपना इलेक्ट्रॉन वापस दे रहा है, तो बेंजीन का जो वो एक फालतू का ऑर्बिटल नहीं था जो कुछ भी नहीं कर रहा था, NO2 ने उसी को खींच के अपने साथ जोड़ लिया, तो H ने अपना इलेक्ट्रॉन दे दिया कि बेंजीन को इलेक्ट्रॉन वापस मिल जाए. अच्छा, anyways, this is the mechanism, and the conditions are tough, but then we studied derivatives, जिसके अंदर हमने पढ़ा था ये चीज, phenols पे डायरेक्ट चले जाते हैं कि electrophilic substitution of phenols. उसमें हमने डिस्कस किया था कि if there is an OH attached or an NH2 attached, तो O के लोन पेयर्स जो है ना वो मिक्स अप हो जाते हैं इसके साथ, बेंजीन के साथ, which increases electron density 2, 4, 6 positions के ऊपर. And the same is true with NH2. NH2 or N also has lone pairs, and the lone pairs they start overlapping, and 246 position per electron density increases a lot. Now the thing is that if the electron density is higher, uh, if the electron density is higher, the reaction would be much easier. The nucleophile, let's assume it's NO2 plus 1. Now it's positively charged, so if the electron density over here is higher, it's going to get attracted more strongly. It's going to be more strongly attracted to it. So a lot faster reaction happens. और इतना फास्ट रिएक्शन होता है कि आपको कंडीशंस ही चेंज करनी पड़ जाती है कि नाइट्रेशन ऑफ फिनोल्स में ना just by using dilute nitric acid you can pretty much do the job. कि one of the NO2 you don't need concentrated sulfuric acid or nitric acid or anything. ठीक है अब्दुल्ला क्लियर है ये बात? हेलो अब्दुल्ला आवाज आ रही है? आयशा इज दिस क्लियर?
Yes, sir.
और ब्रोमिनेशन में होता था कि फिर तीनों कंडीशन से सिर्फ Br2 aqueous यूज करते थे. No special conditions were required. And अच्छा you add a phenol और तीनों पोजीशंस के ऊपर ना ब्रोमीन्स ऐड हो जाते थे 2, 4 and 6. वैसे बड़ा मुश्किल होता था ब्रोमीन ऐड करना कि in normal conditions normal जो deactive benzene है ना उसके अंदर अच्छा उसके अंदर ब्रोमीन ऐड करना बड़ा मुश्किल था. You needed a catalyst क्योंकि बेंजीन का जो इलेक्ट्रॉन क्लाउड होता था that wasn't very dense. ठीक है उसमें इलेक्ट्रॉन्स were very distributed. So ब्रोमीन का जो मॉलिक्यूल होता था ना that did not get polarized. I mean, the electrons over here, they tried to push these electrons, but the force of pushing the electrons was not very strong, which is why the partial negative and the partial positive charges on bromine, they were not very, very strong. And which is why you needed a catalyst. Fe, on the other hand, would attract those electrons, ताकि वो bromine का जो molecule है ना वो बीच में से टूट जाए, electrons इस side पे चले जाए. So that's the question. Okay, it's going to be all three positions. Name the mechanism of the reaction for forming compound E. So that's electrophilic. ये जितने भी हम mechanisms कर रहे हैं, they're all electrophilic substitution. Then it says that phenylamine reacts with aqueous bromine to give compound F. Describe the appearance of compound F. This was also used as a test for identification. A white precipitate would be formed with bromine, जो हमने यहाँ पे लिखा भी था कि फिनोल्स का जो टेस्ट है ना ऑफ आइडेंटिफिकेशन ये 246 डायरेक्टिंग ग्रुप्स वाला. ठीक है कि इफ यू रिएक्ट इट विद और ये मैंने कहा था कि either phenol or phenylamine, both of them are going to react in the same way. So if they're reacting with bromine, so bromine जो है ना no catalyst needed, bromine would get attached to positions 2, 4 and 6, all three positions simultaneously, and a 246 tribromophenol white precipitate is going to be formed. तो यहाँ पे white precipitate लिखा हुआ है. And the next one is phenylamine reacts with nitrous acid to form a diazonium salt. State the conditions for this reaction. इसके लिए you needed a temperature less than 10 degrees centigrade. ठीक है those were the conditions that were needed for this reaction, and NaNO2 and HCl were required. ये acidize का question था. This was something that we did right at the end. ठीक है बिल्कुल end पे. तो end में बस वो acidize हम revise कर लेते हैं कि nitrogen compounds के अंदर this over here कि you took a phenylamine. Acidides were very stable dyes. You took a phenylamine, उसको NO2 और HCl के साथ react किया at temperature less than 10. And it would end up forming this unstable compound which is known as a diazonium ion, and this diazonium ion has a positive charge on N triple bond N, The positive charge would get attracted to another benzene, which is क्योंकि उसके पास electrons है, electrons उसके attract होंगे triple bond +1 के साथ, and this has to be activated. So it's either phenol or phenylamine, either NH2 or either OH attached to it, ताकि electrons और ज़्यादा हो जाए इसमें, and the attraction with diazoniamine is even stronger. So, and that would result in the formation of this azo group, which is your azodie. तो ये इस रिएक्शन की कंडीशंस थी, रिक्वायरमेंट्स थी. बस ये फिर हम नेक्स्ट क्लास में करते हैं. आयशा कोई क्वेश्चन तो नहीं है? अब्दुल्ला एनी क्वेश्चंस? चलिए ठीक है, नेक्स्ट क्लास में ये पेपर कंप्लीट करते हैं. ठीक है, ओके, टेक केयर, अल्लाह हाफिज.